And also, actually, we have a section manager. Let's go to the section manager. The section manager can be used to input the scale factor for the correct section or the long-term section, etc. And also you can see the more detailed shape of section. So this is each, it means the element number 1 and element number 2. So there are 3 types in the section manager. So one is stiffness and reinforcement, and third one is stress point. Let's see. The stiffness show this. If you choose a stiffness, it shows only section which is assigned to the element. So, and also each element will show their section, and also you can see the section for the 5 parts of element. So this is IN, this is JN, and these are the quarter part and the half length and third quarter. And also each part you can see the stiffness. Stiffness means section properties. So without creating the additional section, you can check their detailed section properties here. And also, if you have a tandem profile in your section, like this cantilever, balanced cantilever girder, bridge girder. Oh, sorry. We have this kind of tandem profile. We could have this profile, and sometimes we need to check their coordinates of their coordinate for the tandem profile. So at the right below side, you can see the detailed coordinates of tandem profile. And also to see, if you want to see the tandem profile location, check on the tendon and properties and duct core. So here you can see the graphical view, and also the exact coordinates of this tendon profile here. And if you input the rebar reinforcement, you can check the rebar the coordinates here. And here is the important part of the section manager. So you can input the scale factor for the correct section or other section part. So you can input the scale like this. And you can find the boundary condition. So it is, if you want to assign the different section that has a different scale factor to the different load case or different construction stage, we need to assign the boundary group. So after make this section scale, you can see the group, assign the group. So you can use this group in the construction stage. So you can activate the scaled stiffness, or go to the analysis tab, and here is the boundary change assignment. And you can find the section stiffness scale factor. So you can select the boundary group here. So make the boundary group, and and other, you can also add other boundary condition here, and you can assign this boundary group to check the effect of the scaled sectional properties. Okay, and let's see other section. Okay, I bring some with leaders. So we remained reinforcement and stress point. So reinforcement shows all section, and also you can input the longitudinal reinforcement and the shear reinforcement here. So there are two types to define the reinforcement. So actually this input for the design feature of MIDAS series. So after this webinar, if I conduct the webinar for design features, I will input this more detail about reinforcement. And so if you define the reinforcement, and if you want to get some effect, the reinforcement for the analysis, actually you can find the main control data in the analysis. Here, you can see the consider reinforcement for section stiffness calculation. So it means the software consider the reinforcement area or other section properties to calculate the section stiffness for the analysis. And here is stress point. So this stress point shows the all section, and all section has their stress point. So you can see the number, the 1, 2, 3, 4, 5, 6, etc. So if you define the PSC section, it has the 10 points as a default value, and another section has 4 sections, so 4 points, so 1, 2, 3, 4. It is regarding the leisures is section stress beam stress option. So as you can see, there is a 1, 2, 3, 4, right? So for the default value, for the default section, you can see the stress leisures at the point number 1, 2, 3, and 4. And also there is the beam stresses leisures function for PSC section. So we called it the beam stresses PSC. So as you can see, there are more points in the example figure. So let's see. So when you check the leisures table will show the leisures for the 10 points. So 10 points is, let's say, can be matched to these 10 points. And the additional option is MIDAS Civil has a beam detail analysis function. So from this function, you can check the more detail between the node, detailed leisures between the node I and j for each element. So I will check the element number 1. Okay. Okay, we will see the presentation because it takes a bit of time. So yeah. So after using this function, we can see the more detailed the ledgers about for the 10 points. And also you can see the section manager here. So you can, if you click the section manager, you can move to the section manager option. And here you can add more point to check the ledgers. So after add the point here, click and click the apply button, you can see the additional ledgers in the beam detail analysis ledgers. Okay, it is working now. Okay, let's see. Okay, let's see the main part with the presentation. Okay, third one is plate stiffness scale factor. So if you want to design, if you want to model the crack the plate element, we have a two choice. So one is define the orthogonal material properties, and the other one is use the plate stiffness scale factor function. So you can just select the plate element and input some scale for the each side and just click apply button. And here's effective width for the calculating the bending stress. So you can define the effective width in the boundary menu, and you can find effective width here. So you just select the element and input the scale factor here. And also the effective width function can be found in the structure menu. So go to the structure menu, and there is a three type PSC bridge and composite bridge and steel girder bridge, and it had each option. So first of all, you should define the span information, and after that click effective width, and it has each design code. So after entering some value to calculate some effective width, so the software will calculate the effective width here. And this is the last part of today's webinar. So frequently asked question. So question number 1 is, I got elements which had distorted sections, and sometimes taper section appears one line like this. When I define a taper section using a section from SPC, what happened? So this issue is regarding the vertex of section. So as you can see, the all section properties are inputted properly, but the graphical view doesn't show the right section view. So, but this issue can be happen can be happen for the various regions. But here is the one region. So when we create the section from index SPC, we need to create a node and connect the node by a curve. And also sometimes we can import the drawing file from the AutoCAD like this. So let's say we have a three section. So you when you make our section, sometimes we have a mistake to draw the another section, like using this section and and modify or adjust this section like this. So sometimes it makes some vertex issues. So as you can see, there are two additional vertex. So it has three vertex, 1, 2, 3. So but this section is similar to this section, but it has just two vertex. So at this time, to avoid this issue, we should divide the line to get the three vertex. So I divide this small part. So I have three vertex, 1, 2, and 3. So after modifying this line, so we can get some more proper graphical view for the taper section. Okay, next one is when I check combined stress results, it doesn't appear reasonable values. Yeah. So it is to solve this issue, we need to check the model in various ways, but sometimes you can find the solution in the in the section properties, because before checking the region, we need to understand how to calculate the stress regions in MIDAS civil. So we can see when we check the beam stress regions table, we can see the component, so axial stress and bending Y, bending Z, and also we can check the combined number 1, combined number 2, and 4. So at this time, the software used a different value to calculate the stress regions. So as you can see, to calculate bending stress for y-axis, it used the CYP. CYP means the length, the distance between the centroid of section uh, to the outer section of outer section. No. Okay. So you can see the CYP and CJP like this. So CYP can be the y-axis, the positive direction, so the distance between the central point and this side, this side. And the CJP means that in the z-axis to the positive direction, but sometime the point, the 4 point doesn't match it. I'm sorry, doesn't match it to the CYP or CZP like this, because when you use the value type, okay, like this, we can modify the Y or the point location here. So it can be modified like this. So you can see the moved point here. And sometimes when in SPC, when you use SPC, and the SPC calculates the section properties, but sometimes if the section is complex, has a complex shape, the SPC doesn't calculate the proper the location of 4 points. So sometimes this issue is happened. So this example is not matched the point location to the CZM or other things. And last one is it necessary to use change offset option? Yeah, where is mouse? Oh, I'm sorry. So I would say it is optional. So using change offset is depending on designer's decision. So when change offset is applied, the centroid point will be moved to assigned location. So in perspective of graphical view, the section is just moved with some eccentricity length, but in other view like software will make a U structure that has elements with link between the original point and moved point, like this. So therefore, as shown the figure, where's the mouse point? Yeah. So as shown the figure, the software calculates analysis with the internal structure condition. So when designers build a model, they might have some assumption like to ignore extra forces due to it is too small. So change offset is to modify boundary condition and structure condition. They might face unaffected results depending on their modeling state. So therefore, I would like to recommend to use it on a case by case and to check the effect of change offset. So this is some example using change offset. So you can use change offset to avoid creating additional link between the gutter, or to avoid the graphical issue for the balanced cantilever bridge. And also you can use the change offset option to make up the glitch model in the same plane, and also same plane, and to want to get the more proper results from the analysis.